Let us continue talking about the applications of ODEs. We're going to talk about a mixture problem. Let's take a look at the following example. In this example, suppose that a large mixing tank initially holds 300 gallons of brine, another brine solution is pumped into the tank. These are the information that we have here. This brine solution is pumped into the tank with the rate of 3 gallons per minute. And the concentration of salt in this inflow is 2 pounds per gallon. When the solution in the tank is well stripped, it's pumped out at the same rate as it was entering. Let A of t, so we are defining a function, denotes the amount of salt which is measured in pounds in the tank at time t. So we're going to write a differential equation connecting these together. The rate of change at which the amount of salt is changing with respect to time can be written as, well, the input rate of salt minus the output rate of salt. Which is actually just the net rate. So how do we solve this differential equation? This is our model, and we try to write this mathematically. Let us denote the input rate of salt as R sub in and the output rate of salt as R sub out. How do we formulate these two? So first of all, the input rate of salt, R sub in, can be modeled as concentration of salt in the inflow times the input rate of brine. So the input rate of salt is equal to, what is the concentration of salt in the inflow? Let's take a look at the question. The information that is given to us is, hey, the brine solution is pumped into the tank with the rate, well, we have the rate, 3 gallons per minute, and the concentration of salt in this inflow is 2 pounds per gallon. Well, okay. So far, we know that R sub in, or the input rate of salt, is 2 pounds per gallon times the input rate. What is the input rate? 3 gallon per minute. So what do we get? We get 6 pounds per minute. Now let us formulate the output rate of salt, R sub out. Again, here we have the concentration of salt in outflow of salt in the outflow times the output rate of brine. What information are given to us? So first of all, the concentration of salt in the outflow, remember that initially we had 300 gallons of brine in the tank. So it's going to be the amount of salt divided by 300 times the output rate. Remember that the question says, hey, the output rate is the same as the rate of the entering solution. So you're going to have 3. So pound per gallon times 3 gallon per minute. If we simplify this, the output rate is going to be, well, A of T divided by 100. There you go. We have our differential equation. The differential equation says, hey, the rate of change with respect to time is equal to 6 minus A of T divided by 100. First of all, this differential equation is separable. You can check to see if it's linear or not. Of course, it's linear. Then you can solve by any appropriate method that you feel comfortable working with. If we work with the separable differential equation, we get dA dt equals to 600 minus A of t divided by 100. So dA divided by 600 minus A is equal to dt over 100. If we solve this differential equation, first of all, on the left-hand side, we have negative natural log of 600 minus A of t equals to, well, we get t divided by 100 plus a constant of integration. There you go. So if you multiply everything by negative sign, you get negative t plus c sub 2 Now 600 minus AT is equal to e to power negative t over 100 times plus minus e to power c sub 2. So A of t becomes 600 minus e to power negative t over 100, and this is called c. So again, A of t denotes the amount of salt measured in pounds.